So we're going to be talking about just some introductory approach to Python today. And to go through this, I'm going to start by sharing my screen. So let's make sure this works. And well, that's interesting. Are you all seeing the schedule for the NeuroHackademy right now? Okay, excellent. So everything we're going to do in this session is going to be done in just in a web browser using the Jupyter Hub. So to start with, we're just going to kind of get you introduced to the Jupyter Hub. Now, some of you may have used some of these tools before. Some of you may have used Jupyter before, or be a little bit familiar with Python. That's totally fine, but this tutorial is geared towards people who have maybe had a little bit of programming, but who aren't experienced with Python. So just understand that it will probably go a little slow if you're a bit experienced, but also it's okay if you need to slow it down, or if we need to slow it down. Feel free to ask me questions at any time. I'm more than happy to stop and answer them. So with that, let's go ahead and get started. To start with, we're going to go to the hub. So just browse to hub.neuro.org. That should bring you to the hub site, and everything we're going to do today will be fine in the small instance. So I'm just going to go ahead and start this small instance, and this will take just a moment to start. Now, what this is actually doing is this is starting up an instance of a Jupyter Lab server on some Amazon Web Services computer somewhere. And so all of the things we're going to be doing are running in the cloud. Like we said, everything is persistent. That's because the service we're running knows to keep track of all of your individual user directories, and so all the kind of editing we do during this session will be saved in your cloud directories. Okay, here we go. All right. Now I'm going to close this because this is probably something we don't see. These were some things I was doing earlier. So you should see a window that looks something like this. You should see this launcher window with a notebook, console, and other. You should see this little side panel that shows you like a curriculum and a data. You probably don't have this Untitled notebook, and that's fine. Does everyone see something kind of like this? If you don't see something like this, could you raise your hand or say something? Or if you have any questions about it, go ahead. Hetfi, I cannot hear you.
Okay, no, I clicked on the plus sign to get to the launcher, but now I see something like that.
All right, so this is Jupyter Lab, and what this panel here on the left is showing you is just kind of a view into the file system. So this is just your own directory. And well, the first thing we want to do is go ahead and launch a Jupyter notebook. So for that, you just need to click on this Python 3 button, and that will start a new Jupyter notebook. In this case, Untitled 1 for me. It probably is Untitled for you. That's totally fine. That's only because I made one of these earlier. And you should see a window that looks something like this. So this is a Jupyter notebook. You may have used them before using just a Jupyter Hub rather than a Jupyter Lab server. If that's the case, this is probably familiar, but maybe a little different. But basically, Jupyter is a tool for interactively using Python. At least that was what it was originally used for. And since being developed for use with Python, it has grown into a much broader tool that can be used with lots of different languages. So just to kind of give you a sense of what Jupyter is, it's an open source web application that lets you create and share documents. And these documents contain code, they can contain text or formulas like mathematical formulas, and they can contain the outputs of code like plots, which I think you saw just briefly in our earlier session. And we're just going to kind of walk through this for a few minutes first, and then we'll dig into Python specifically. So the way a Jupyter notebook is structured is that you have these things called cells. So this block here is a cell in our notebook. And we can enter whatever we like here. I'll start by entering just a simple print statement. This is a Python command. and this is Python code. If you haven't seen this kind of code before, that's okay. We'll talk about Python in just a moment. But basically, we've entered some Python code into this cell. And you'll notice that if you push enter, it goes to the next line. And you can enter more code. If you want to actually run the Python code in this cell, then what you do is you hold down either Shift or you hold down Control and you push enter. So go ahead and hold down Shift and push enter. And you'll notice that what it does is it prints out hello world, then it prints out line 2, and then it creates a new cell beneath the current cell. That's basically how you evaluate a cell in Jupyter. Now, if instead of pushing Shift enter, let me put another line here. If we had pushed Control enter, we would have gotten the same thing, except it didn't make another cell beneath this cell. So if we want to add a new cell, we need some way to add to do that. So one thing we can do is you can go ahead and click in the cell that you've already been editing, or you can push enter and it'll take you into that cell and you can go ahead and edit it. So we could edit this and say, and yet another line. And then we can push Shift enter and run it again. And you'll notice that the output here replaces the previous output. So this is basically how we evaluate cells in Jupyter. Any questions so far? Okay. Now, you'll notice that when I'm editing this cell here and I push enter and I push up and down, the up and down keys, I stay entirely inside this cell. And if I continue to push up, I'll go up to the next cell. So that's one way to get around the cells. But additionally, when you're editing a cell, you can push the escape button. And you'll notice once I do that, the cell is no longer highlighted. You're now in sort of a meta editing mode, where if you push up and down, you sort of select different cells. There are a whole bunch of keyboard shortcut commands that are available in this editing mode, as opposed to the cell editing mode. One of them, for example, is the B button. And if you push B, it'll insert a new cell right below your current one. So if I push B again, it inserts a new cell below my current one. I'm now going to go up, and push enter. And now I'm editing inside of this cell. And if I push B, it just inserts a B. Does that make sense to everyone? Okay. Again, just please interrupt me if I say something that doesn't make sense. We have a small group, so it's totally fine. All right. Similarly, if I push escape and get out of this cell back into editing mode, I can push the A button for above to make a new cell above the current cell. Now, there's a help menu here, and there's a whole bunch of different references here. But for the most part, I believe whoops, not that one. I believe there's a list of keyboard shortcuts in the Ipython reference. Oh. Apparently not in the Ipython reference. Well, apparently this version of Jupyter doesn't have the keyboard shortcuts listed. Sorry. All right, well, I will just tell you the other keyboard shortcuts, or at least the important ones. The first one is that if you want to delete a cell, you can push D twice. So if I push DD, it deletes that cell. I can push DD again and it'll delete another cell. And then finally, there are some other kind of useful things that you can do to these cells. For example, if I go up to kernel, there are various ways to restart the kernel and clear all outputs. So I'm going to go ahead and select this option now. And what this will do is it'll actually restart the Python instance that is running. Whoops. And when I click restart, it will also clear all the outputs of the cells that we previously evaluated. And I'll come back and mention this again later. This is kind of an important concept, but we'll talk about it later.
I have a question.
So these, yeah.
Does restarting the kernel also get rid of the markdown in the file?
No, it does not get rid of markdown. So that's that was actually what I was going to talk about next, is the markdown. So restarting the kernel and clearing the outputs only gets rid of the outputs of code cells. And so far, these are code cells because they contain Python code like print. So I mentioned at the beginning that you can not only put code in these notebooks, but you can also put documentation and math formulas. So another one of the shortcut keys, if I push escape so that I'm in edit mode, I'm not in a cell, and I push the M button, you'll notice that those little brackets disappear. That's because I've just made this cell into a Markdown cell. Now, if you're not familiar with Markdown, Markdown is a very simple sort of text format for writing web pages. So let me just give you an example. So if I put a single hashtag and then I say, this is the document header, that is a way of telling Markdown that everything following that hashtag should be like a title or a big header in the document. So now I'm going to type some text. This text is part of the first paragraph of the first section. Now let's go ahead and evaluate this cell by pushing Shift and Enter. And since this isn't code, we're not going to get an output in the same way. Instead, it renders as text. And you can see that this is the document header, which we marked with a hashtag, gets rendered as a header, and this line of text gets rendered as text. Now, I'm not going to go over everything you can do with Markdown. Markdown has all kinds of useful stuff in it, though. Just a couple examples. If you separate two lines by a blank line, it makes a new paragraph. So this is a new paragraph. And this here, I'm going to insert an HTML link. So this, and we'll just have this be a link to the hub. So you notice how I put this in brackets, and then after it, I put in parentheses the link. So when we push Shift Enter to evaluate this cell, we now get this rendered as text with a link. And if I click on this, it'll go to hub.neurohackademy.org. I'm not going to click on it right now. Let me just show you a couple more things. We'll make a list where we have a few elements. And when I push Shift Enter to evaluate this, we get a list at the end. So this is just kind of a sense for how you can include documents in these Jupyter notebooks. And I highly encourage you, as you're editing things in Jupyter notebooks, treat these kind of like comments in code, where you kind of write little bits of documentation to explain what you're doing in various parts of any notebook you're editing. And I'll try to use this kind of as we go during this tutorial, so you can see some examples. All right. I apologize. I'm getting a phone call on my phone that's ringing through to my headphones. Okay. All right. So one more thing I want to show you is that if you have a Markdown cell, oftentimes it's very useful to put a little bit of LaTeX math notation in your cells. Now, if you're not familiar with LaTeX, don't worry too much about this. LaTeX is just a kind of fancy way to put math equations into text. So you can go ahead and insert math equations into a Markdown cell by using the $sign character. And just as an example, I'll say y of t equals sum from I equals 0 to n of x to the n. Now, if that all looks like gibberish to you because you've never seen LaTeX before, don't worry about it. I just want to show that this is possible for now. So here you can see that it inserted a nice little math equation based on what I typed. This is a LaTeX formula. So once again, don't worry about this if you haven't seen LaTeX. I just want to make sure you know that that's possible. So this is basically a very quick introduction to to the way that Jupyter and Jupyter's cells work. Are there any questions about this before we go on and start talking about Python? Keeping in mind that we will be using this notebook to look at Python, and we'll kind of get a little more experience with these cells and things as we go, and I'll try to narrate them as I go. But any questions so far? Yeah, go ahead.
You might have said this before, but I had to get up for a second. How do you go from one cell to the next with the keyboard?
Yeah, so typically if you're inside a cell like I am right here, you start by pushing escape. That takes you out of the cell to the sort of notebook editing mode. And then you can just use the arrow keys. You can go up or down. If you want to insert a new cell below, you can push the B button for below, and that inserts a new cell below. If you want to insert a new cell above, you can push the A button for above, and that inserts a new cell above you.
Okay,
that answer your question?
Yeah, thank you. And then what exactly is Ipython?
So Jupyter kind of grew out of Ipython. Ipython was originally an interface for Python, and honestly I don't know the whole history here, but Jupyter is a flavor of Ipython in a sense. So there are Ipython versions that work just in a terminal, like as text only, but they're still meant to be sort of interactive Python instances. Whereas when you run Python by itself, not just the Python command, it's not really made to be interactive. It's more made to be like a program that's running your code. Does that make sense?
Yeah, thank you.
Cool. All right. Any other questions before we kind of move on? All right. So there are quite a few other features of Jupyter, and I guess I just want to mention one more of them, and that's that there's a special kind of command that you can put in a cell that starts with an exclamation point. So this Jupyter instance is running somewhere on this hub in your file system, and there's also an operating system on that on your hub, and so you can interact with the operating system by using the exclamation point. So we can just go ahead, for example, and type the ls command after the exclamation point, and then when we push shift enter, what it does is it actually runs ls on the server and just gives us the output. It's not a Python command, it's a terminal command for bash. So I could then say, so this is telling me I have a file untitled untitled1.ipynb, and then the directory's curriculum and data. So I could, for example, say ls curriculum, and that gives me everything in the curriculum directory. So this is just a way to very quickly kind of interact with your server. There are some other features of Jupyter that I think are important, but that aren't important enough for us to go over them right now. So instead, I'm just going to refer you to in this curriculum directory, in the Python intro directory. In fact, let me go ahead and just show you while we're here. Oops. If I ls curriculum / Python intro, you'll see that there are 3 files in there. One is 01-Jupyter Notebooks, one is 02-Introduction to Python, and the last is a PDF. We're actually just going to walk through the contents of these notebooks during this session, and I'll be explaining things as we go. These notebooks are meant for references for you. So this 01 Jupyter notebooks.ipynb contains a whole lot of documentation, as well as a bunch of the Jupyter commands and features and things. So you can come back to that later and look through it if you need more help. Same with the introduction to Python. You can come back to that if you need more help. And just to show you how to open those specific files up, you can use this side menu, and you can go to the curriculum and then click over to the Python intro. And then if you want to open up Jupyter, the Jupyter Notebooks notebook, you can just double click here, and this will open up a bunch of information about Jupyter Notebooks and how they work, and other things that we're not going to necessarily cover right now, but extra information for you and extra resources there. All right. And let me just close that. Any questions before we keep going?
Actually, I do have a question. I can see like a green dots close to 01 Jupyter intro on my folder.
Like this.
Yeah, exactly. I wonder why.
Yeah. So that means that this notebook is currently running. So I opened this notebook, and that meant that it started the notebook running kind of in the Jupyter system. If you want to shut down, if you want to stop it, there's an option here. If you just right click on that, the file name, you go down to shut down kernel, and that will shut down the resources that are running that notebook. Now, when I say running that notebook, what I really mean is that Jupyter has a Python program running in the background, waiting for you to evaluate a cell. And if you start it over, then anything you've previously evaluated in the notebook will be lost. Now, all your code will stay there, but if you set some variables, that'll be lost. And if that doesn't totally make sense yet, then I'll kind of re-explain it again in a minute once we've done a little bit more Python code.
Okay, thank you.
Okay. Yep. Any other questions? Okay. So let's go ahead and switch gears and start thinking about Python. All right. So I just want to get a show of hands before we start. How many of you have previously used Python in some small amount, like you've either used it to edit a script, or you've maybe edited a little bit of code, or worked on a project that used Python? How many of you have a little bit of experience with Python? Okay. So it looks like a good number of you have some experience. Okay. So I'm going to lower everyone's hands, and I can't lower everyone's hands. There we go. Okay, now, how many of you have how many of you have experience with at least one other programming language, where you've at least done a little bit of programming in some programming language of your own? Okay, okay, great. Excellent. So that's useful for me to get a sense of kind of where everyone is. All right. So Python at its core is kind of, it's a relatively easy to learn, high level, general purpose dynamic programming language. So that's a lot of different things. So I'm just going to kind of walk through that. Now, first of all, I said that it's an easy to learn language. And when I say that, I would just want to say I don't mean that programming is easy. Programming is generally hard. But relative to sort of the amount of experience you need to have with, for example, details of computer hardware, or details about how operating systems organize data, Python is pretty easy to learn because it doesn't require you to know a lot of those details. It's made to be fairly close to the way we think about how computers work, and in fact, a lot of its syntax is made to be very human readable. So in that sense, it's easy to learn. In that it's easy to learn as kind of a first programming language. It's also a general purpose and a dynamic programming language. So when I say general purpose, I just mean that it's useful for a lot of things. There are a lot of tools and libraries in Python that make it easy to do just about anything you want to do. Many languages are very specialized. So like C and C++ are great languages, but they're very specialized for certain kinds of computations. Python is very good at almost every kind of computation, and that's a really good feature of it. It's also dynamic, or what you might call interpreted. So if you've ever worked with a language like C or C++, one of the features about those languages are that you have to write your code, and then you have to run a compiler, which turns it into a program, and then you run the program. Python's not like that. Instead, you start up Python, and Python runs some program that takes the code that you write and interprets it for you. So it kind of does a lot of the work. And ultimately, what this means is that a lot of times you can get by in Python as specific as you do in other languages. You don't, for example, have to declare what types things are, and that'll make more sense in a minute when we talk about types. So having kind of explained this, I'm just going to start by giving us some very simple, basic Python code to look at. So I'm going to come back over to my notebook. I'm just going to make a few cells here to scroll past. And we'll start by just declaring a variable. So we're going to declare a variable called my favorite number, and I'm going to set this equal to 2. All right. So if I push Shift Enter, the Python interpreter is going to take this piece of code and it's going to evaluate it, and it's going to print the output below it. Now you notice that it didn't print anything. That isn't because something went wrong. It's because this particular piece of code doesn't have any result. All this does is it declares a variable called my favorite number, and it assigns the value 2. So we can now, in a new cell, evaluate my favorite number. And if I push Shift Enter here, it will print out 2 as the output. Also, just as an aside note, notice that there are these numbers here on the sides. These are actually counting how many things I've evaluated. So this was the 4th line of code I'd evaluated, and this was the 5th line of code I would have evaluated, and this is just the 5th output. That's all it's telling me. All right. So if you're familiar with a language like C++, in those languages, you typically have to say something like int my favorite number equals 2. Basically, what this says is you're declaring this variable to be an integer, and then you're setting it to 2. But in Python, you don't have to do that. And in fact, there's nothing stopping you from saying, OK, I've set my favorite number to 2 in this cell, but now I want to change it to something else. I'm going to change it to 2, a string. And this a string is anything between these quotes, which I'll talk about a little more in a second. But we can go ahead and evaluate this. Again, there's no output. And then we can evaluate my favorite number, and we get the response 2. So unlike in C, you don't have to declare what type of variable is before you assign it a value. You can just assign it a value. Now, can I get a quick show of hands? How many of you have worked with strings before? And specifically, are you familiar with this syntax? So if so, would you please raise your hand? Okay, so let me just explain it real quick. And we'll go over strings a little bit more carefully in a bit. But in most programming languages, including Python, numbers are quite a bit different than strings. So a number like 2 or 10 or 10.7, for example, these are all different kinds of numbers. On the other hand, if you put a number like 10.7 in quotes, that's not actually a number. Instead, this is what's called a string. And sorry, 1 second. I'm having trouble getting my participants open. There we go. Okay. Yeah, this is what's called a string. So what this string actually is, it's not a number in memory, in computer memory. Instead, it's a sort of list of the character 1, and then the character 0, and then the character period, and then the character 7. So basically, this is text that happens to represent a number, whereas this is an actual number in memory. Does anyone have any questions about that? Okay, great. Okay. So let's go back to this fact that when I ran this first cell, it didn't print anything. So I mentioned that we can run my favorite number like this, and it'll print the result because my favorite number is equal to the string 2, which we set here. It prints out 2. But what if we have multiple things in one cell? And sorry, my notebook is freezing up. There we go. Okay. So what if we first set my favorite number equals 2, and then we have my favorite number, and then we go down here and we say my favorite number equals 3, and then we have my favorite number again. Well, what's going to happen is it's going to run each of these lines of code in sequence, one after the other. So the first thing it's going to do is it's going to set my favorite number to 2. And then the next line just evaluates my favorite number. So the result of this line is 2, but it's not the last line in the cell. So Python's just going to keep going, and it's then going to set my favorite number to 3, and then print out my favorite number, or rather evaluate my favorite number. And since this is the last line in the cell, it's going to print it out. So let's go ahead and push Shift Enter and see how that looks. And you can see that the result is 3. So it's not that Python prints out things that aren't an assignment statement, or it prints out every line. It only prints out the last line in this case. If we wanted to print out this number here, we could instead use what's called a print function. So I'm going to go ahead and set pretty much the same thing. My favorite number equals 2. And then instead of just having my favorite number by itself on the line, we're going to say print my favorite number. Then we'll set it to 3, and we'll do the same thing. And we'll print my favorite number. Now if we run this, oops. Oh, that's funny. For some reason, it did not print that. I think my cell got changed somehow. Let me just copy this. Apologies. There's some keyboard shortcut that's interfering with my ability to edit my cell here. There. I hit a key wrong, and this cell down here turned into a different kind of cell, which we're not going to talk about. So you can just ignore that for now. Okay, so this time we set my favorite number to 2, and then we printed it, and so we can see 2 printed here. And then we set my favorite number to 3, and we printed it, so we can see 3 printed here. All right. Any questions so far? Okay. Now, the print command is actually fairly flexible, and it's what we call a function, and we'll talk a little bit more about functions a bit later. But just to add some decoration, I'm going to edit this cell, and I'm going to put a little bit of decoration around the printing of these numbers. So I'm going to put a string here, and it's going to say, my favorite number is, and then I'm going to put a comma, and then my favorite number. Now, what this print function will do is it will print everything to the screen that's kind of passed to it. And so this will print out my favorite number is, and then 2. And we can do the second. We can do the same thing for the second line here. And now when we push Shift Enter, we see my favorite number is 2 and my favorite number is 3. So the print command is very useful. It's often used in debugging. You write a kind of complicated code, and then you want to print some stuff to make sure that various variables have values at a particular point in the code. All right. So I'm going to go ahead and delete these cells. For some reason, like this cell below me, I'm not sure what I did there, but we'll just go ahead and insert a bunch of cells. All right. So I've shown you some numbers. I'm going to make a new variable called age in years, and we're going to set that equal to 30. So this is a variable that might represent a person's name, a person's age. And we can go ahead and evaluate that. Now, this is an integer. And as you might expect, we can use basic mathematical operations to do basic math with this variable. So if, for example, I said age in years plus 5, we'll get back 35. No surprise there. However, what if I divide it by 2? So in some languages, when you divide an integer by 2, you get half rounded down. And this is not a great example. So let's, since age in years is even, so let's go ahead and make this age in years plus 5 divided by 2. So one possibility is that we will get back 17 and a half for half of 35. The other possibility is that we'll get back 17. In languages like C, you get back 17 because integers are integers, and when you divide them, they stay integers. However, in Python, Python's smart enough to know that what we want back here is a number with a decimal point. So when we evaluate this, we get back 17 and a half. So division works pretty much like addition. It works correctly, whether your number is an integer or a real number or whatever. Now, I just want to take a brief second here. If you're pretty new to programming and you have never dealt with integers and floating point numbers before, I just want to very quickly explain that in computer memory, integers and floating point numbers, that is numbers that are not integers, like irrational numbers and real numbers, they're represented very differently in computer memory. And so in many languages, you have to very explicitly convert integers to real numbers and vice versa. And in Python, for the most part, that is handled for you. You can just think of numbers as numbers most of the time. But for reference, these are usually called real numbers or floating point numbers, and these are integers. Any questions about that so far? Okay. So let's look at just a couple other examples. Suppose you have something like age in years. I'll just copy this. And we want to get something like the nearest integer. Well, there's a function called round that's built into Python. So if we run this, we'll get 18 because it will round for us. And in fact, this is a pretty intuitive function. Round is something you might expect to be in Python. There are, in fact, a whole bunch of these kinds of functions. I'll just show you a few of them. One of them is the absolute value function. So you can say absolute value of -5 is 5. There are functions like log. So if you say the log of 5.5, oh, log is not defined. That's because log is part of the math function, so my mistake. However, we can also use a function called int, and that will convert this function into an integer, kind of like the round function, but unlike round, it just drops the decimal off entirely. So even if this were, for example, 5.7, into 5 is just 5. All right, these are examples of very simple functions. And we'll come back to functions in just a moment. We'll kind of see a few more examples, and then we'll talk a little more about them a little bit later in the tutorial. Okay. So let's talk a little bit about strings. Strings are very important because in addition to numbers, strings are kind of the core pieces of data that make up a lot of your programs and a lot of the code. So let's have an example. We've already seen one example, but let's go ahead and have another example. Say country equals Madagascar. So, and then I'll go ahead and print country, as you can see, country. So country equals Madagascar, and then print country, and you can see that it prints Madagascar. Notably, it doesn't print these quotes. When it prints strings, it just prints the contents of the string. The quotes are there so that Python knows that we intend this to be a string and not part of the Python programming language. A couple things about strings that are worth noting. One is that strings can be either between double quotes or single quotes. So I could also say country equals Madagascar like this, and we get the exact same result. There's no difference between single quotes and double quotes. However, on occasion, sometimes you want to put a single quote inside of a string. So a lot of times that is easier to do when you use double quotes. So for example, this string wouldn't work with single quotes. Can anyone see why this string wouldn't work if I had used single quotes? All right.
The apostrophe
So
maybe before the T.
exactly. Yeah, exactly. So this will work right here, and I will just print it out. That's totally fine. However, if I then copy this whole thing, I'm just copying and then pasting. If I change this to a single quote and this last quote to a single quote, Python thinks that this is the whole string because it comes up against a single quote and says, oh, that's the end of the string. And then it doesn't know what to do with all of this, this bit at the end. So if I evaluate this, it's going to give me a syntax error. Now, you'll notice that the syntax error is kind of this highlighted pink color, and it has a little caret that points to the part of the line that it thinks produced the error. So this is Python trying to tell you how it got confused. Generally speaking, if you get an error, it'll tell you what's wrong, and sometimes these are easy to read and figure out what happened wrong, and sometimes they're not. That's just kind of true of every programming language. It's nothing special about Python. But this kind of display usually means you got an error. Okay. Any questions about that? All right. So now I'm going to show you a few operations you can do on strings, and these are all kind of important. But one of them is to look at the length of a string. So there's a function called len, and if we ask for the length of country, it will give us back an integer, 10, which happens to be the number of characters in Madagascar. So this tells you how many characters there are. At this point, we're going to look at a new kind of function. Now, this is just a typical function. Len by itself is a function. And in fact, if we just evaluate len by itself, we'll see that it gives us back this little description that says this is a function named len. Functions are sort of first class. Their functions themselves are objects in Python. They're things you can interact with and query. On the other hand, let's suppose we wanted to take the string Madagascar and we wanted to turn it into all uppercase characters. Well, you might think that there would be a function called upper that would do this. However, that's not the case in Python. If we try to run that, we get this error that says upper is not, I don't know what upper is. Instead, the way you do this in Python is using what's called a method. So country as a string, country is a variable that contains a string, and that string is an object in Python. In fact, pretty much everything in Python is an object of some kind or another. And objects can have methods, which mean that a method is just a function that's attached to that object. So in this case, the upper function is a method that's attached to a string. So what I do is I put the variable name or the string here, and then I put a dot, and then I put the name of the method, and then I put open parenthesis and close parenthesis, and any arguments to that method go inside those parentheses. So when I run this, what we get back is Madagascar all uppercase. Okay. Now, an interesting thing is that country.upper returns this string. That is, when this gets evaluated, it turns into the string uppercase Madagascar. So that string itself, we could also call a method on. So let's take Madagascar, the uppercase string, and then I'm going to put a dot, just like I did here, and then lower as a command, or as a command for Python. Now, since this is a string, this is an object, and so I can call this lower method, which, as you might guess, does the exact opposite as upper, and I can call it on this string, even though this is a string like a literal string, as opposed to a variable containing a string. This will still work. So when we evaluate this, we'll get Madagascar all lowercase. That makes sense to everyone? All right. So for that matter, we can do something like this: country.upper. This piece of code right here, country.upper, evaluates to a string. And so we can put a dot and call lower. And this is exactly the same as what we just did here. This is basically equivalent to calling country.upper and then calling lower on that result. So when we call this, we'll get back Madagascar all in lowercase. So far, so good. All right. Let's look at a couple other examples of these kinds of operators. Oops, country. So let's look at, there's another method for strings called count. What count does is it counts the number of times that a particular substring appears. So let's just use the substring A, and that will give us back 4. And that's for 1, 2, 3 A's of Madagascar. On the other hand, if we said country.count ga, oops, that should give us back just 1, because there's only one GA substring in Madagascar. Now notice that we can pass arguments to these methods just like normal functions. And in fact, you can pass multiple arguments to them, and we'll talk a little more about that in a little bit later. Let's look at one more example of this. Let's do country.replace. Now replace will take a piece of a string and replace it with some other string. So for Madagascar, let's replace car with truck. And what this will give us is Madagascar. So it just took the car string at the end and replaced it with truck. Does that make sense to everyone? Okay, so let me just cover a couple of things real quick here. Let's suppose we did country.replace car with truck. Does anyone want to guess what will happen with this line? So we can go ahead. Go ahead.
Probably, I think it won't work, but let's see.
Yeah, exactly. It won't work. So when we evaluate this, we just get back Madagascar. And the reason is because Python is case sensitive. A capital C and a lowercase c are not the same. That's true inside of strings. It's also true for variables. So for example, if I say a variable equals 10 and a variable equals 12, these are two different values. A variable with the lowercase v will still be 10, and a variable with the uppercase v will be 12. Okay. So we've seen integers, which are just integers. We've seen real numbers, which have decimal points. We've seen strings. There's another kind of value that's very fundamental to Python, and that's called the Boolean value. So traditionally, Boolean values are 1s or 0s, or true and false. In Python, these are true, like this, and false, with capital T and capital F. So if you try to say a Boolean equals true, this will give you an error, because that T in true needs to have a capital T. But you can go ahead and run a Boolean equals true with a capital T, and then everything will work just fine. Now, there are some kind of interesting things about these variables that are a little unintuitive. One of them is that true is equal to 1. This is pretty common. This comes from the fact that in C and C++, false is considered 0, and these are like very fundamental languages, and Python was written in C and C++. So in Python, false is equal to 0. That's also true. Now that isn't to say that this is a little unintuitive, because 0 is an integer, but even though it's an integer, it's equal to false. And 1, even though it's an integer and not a Boolean, is equal to true. This is sort of like how 1 is equal to 1.0. It's the same basic idea. And 0 is equal to 0.0. Even though 1.0 is a real number and is represented differently in memory than 1, they still represent the same concept, and so we consider them to be equal. And the same is true with true. Now, something you probably noticed here was that I used these double equals to see if things were equal to each other, whereas I'm using single equals up here to assign a variable to be equal to true. And this is common in a number of languages, and Python is one of them. So let me just demonstrate this. We can say, let's say a value equals 10. And then a value equals 10. These are two digits. Now, does anyone want to predict what the output will be when I evaluate this cell?
True.
Very good. It will be true. And the reason is because the first thing it does is it sets this variable named a value to 10, and then it checks to see if a value is equal to 10. So we can run that, and it's true. Now, a really common mistake people make in a lot of programming languages is to use equals when they mean equals equals. Fortunately, Python will usually catch that mistake. Not always, but usually it will catch that mistake. This will become more important later when we talk about if statements, but for now, just be aware that it's important to always be sure whether you should use a single equals when you're assigning things or a double equals when you're testing things. Okay, so some other things that we can test. Testing for equality is great, but there's a couple other tests we should talk about. One is maybe we want to see if a value is greater than 5. We can use just a single greater than symbol for that. And obviously a value is greater than 5. Similarly, we could test if a value is less than 5, which will come up false. And finally, we can say, is a value not equal to 5? So to do not equals, we use exclamation mark equals. That's basically how you do not equals. Alternately, there's an operator called not. So we could say not a value equal 5. And this will just return the opposite of a.value equals 5, which is the same thing. So for that matter, we could say not true. Not true is false. Does that make sense, everyone? Okay. That's okay. All right, so just a couple more of these. If you want to do less than and equal to, those are less than equal to symbols. But if you want to do less than or equal to, that's a less than equal to like that, and this is a greater than or equal to like that. So a value greater than or equal to 10, that's true. All right. So I'm going to talk about one more kind of value, and then we'll take just a quick few-minute break since we're about halfway through the lesson. And this value is what's called none. So I'm going to make a variable called none, and I'm going to set it equal to the value none. And notice that the value none has a capital N, just like true or false. None is a special value, and uniquely, when none gets printed, nothing gets printed. So if I just evaluate none here, it's going to act like nothing happens. That's because none is a special value. If you're in a lot of languages, none is instead called null. It's a value that basically means nothing. It doesn't. It sort of indicates that there's no value here. So in fact, when if we scroll up here and we go to one of these earlier cells where nothing got printed out. So for example, this cell here where we assigned age and years equal to 30. What actually happened was Python assigned age and years the value 30, and then it returned a none value. And since none doesn't get printed, nothing got printed. So none is kind of unique. One of the interesting things about none is that it is not equal to false, even though it seems kind of similar to false. So none equal false is false. If you want to check if something is none, you can use a different comparison. Instead of equal, you can say is, you can basically ask something like a value is none. Is similar to equal, but it tests, rather than testing for equality, it tests to see if they're literally identical. In this case, a value is not identical. We set a value to 10, but none is none. Okay, that's maybe a little confusing. Does anyone have any questions about that? Okay. All right, so we're about halfway through the 2-hour period. We're going to start up with collections in a couple minutes, but let's go ahead and take a 3-minute break for bio break or whatever, get some water, and we will start back up at 12:35. And I'll be happy to sit here and answer questions if anyone has any in the meantime. But feel free to turn your cameras off, and we'll restart at 12:35.
Hi, so I had a small question.
Mhm.
So I did everything else was great, but I did the string with code and I tried to print it. And then I don't know, something happened to Jupyter. It won't even let me add cells below that cell.
Oh, really?
Yeah.
So weirdly enough, I think there might be something buggy in the current version of Jupyter we have installed, because you notice how I'm trying to select this cell down at the bottom.
Exactly. That's what it's not letting me
Yeah,
do
it's
that.
doing that.
Yes.
Yeah, I think you might have run into the same issue. So this is something that I've never seen before, where I get this cell that I can't edit.
Yeah. It's not even letting me delete it.
Yeah, so for now, I would just ignore that. That's not a typical problem.
Yeah, coming.
Yeah, in fact, I'm going to see if I can't delete it. Yeah, see, I can't even.
Yeah, exactly. Yep.
Oh, that's too bad. Well, yeah, okay. I would just ignore it, and I'll flag that with our tech team and see if they can fix it.
Okay, thank you.
All right. We're probably still coming back, but while everyone is returning, I'm going to go ahead and type out a bit of a plan for the rest of the lesson here. So I'm going to use this. I'm going to do a Markdown plan here. So when I'm in edit mode in the notebook, I can push M to switch this to a Markdown cell. And then I'm going to say list of the lesson plan. And then I'm going to put a list. So we're going to start by talking about containers. And then after containers, we'll talk briefly about how everything is an object. We'll then talk about control flow. So if, while, for, and we'll talk about importing things. And if we have more time, we'll talk about defining functions. And if we get through all that, we're ahead of schedule. So there's our brief Markdown description of what our plan is. All right. So we'll start with containers. So containers are very important. What we've talked about so far are just like individual numbers or individual strings. But generally speaking, you need to be able to store more than just numbers and strings. So just one second, I need to find my spot here in my notes. All right, so we'll start by looking at a type of variable called a list. So a lot of times you need to have a list of data that you're keeping track of. And lists are stored in Python using square brackets. So as an example, we're going to make some random list, and we're going to it's going to look like this. Now we can evaluate this just like this. This will work, and if we then have it evaluate some random list, it gives us back just a pair of square brackets. This pair of square brackets just represents an empty list, and in fact, if we ask the length, we saw that len function earlier for length. If we ask the length of an empty list, we get back 0 because it's got nothing in it. Now let's put something in that list. So I'm going to say this is going to contain 10, and then some string, and then 5.7, and then some other string. So I'll go ahead and evaluate that, Shift Enter. Now this was an assignment, so it didn't print anything out as a result, but this went ahead and made this assignment. And if, oh, I misspelled that, same random list. Let me just fix this, some random list. If we now print it out by evaluating it in a cell by itself, we get back this list that we just entered. Okay, no surprise there. Now, a couple things to notice. Obviously, this list contains 4 things, 2 numbers and a string, or 2 strings. However, they're not the same kind of object. So this first number is an integer, then we have a string, and then we have a floating point number, and then we have another string. So clearly lists don't have to be the same kind of thing. They don't, for example, you don't have to put just integers in a list or just strings in a list. They can contain whatever you want. All right, so
I had a side question. Do floating numbers behave as doubles do in C++?
I'm sorry, do what numbers?
Do floating numbers behave like a double?
Yeah, so let me actually think about this. I'm pretty sure that the floating point in Python is a 32-bit floating point, so it's like a float. That said, when we talk, so in the advanced Python lesson, we'll talk about NumPy, which is the numeric library, and NumPy has excellent ways to represent doubles and floats and all that kind of stuff separately. Okay. So that'll be a topic for later. But for now, these are basically 32-bit floating points. And in fact, that may depend on your architecture. Maybe that they're 64-bit if you're using a 64-bit computer. Another thing about it, but regardless, that's more about that in the advanced Python lesson. Okay, so so we have this sum random list that we've made. How do we get a single element out of it? Well, one thing we can do is use the square brackets. Now, square brackets are used both to declare a list like up here, but they're also used to access a specific element of a list. So here I'm going to ask for element 1. Now, you might think that element 1 would give us 10. But in fact, if we run this, we push Shift Enter, we get back some string. So this is element 1. Now, why is that? Well, in C and C++ and in some languages, like Python, lists start at 0 instead of at 1. If you're used to MATLAB, which a lot of people in neuroscience do use MATLAB, or Mathematica, I think R is also the same way, lists start at 1. But that's just something that's kind of up to every language. In a lot of languages, lists start at 0. So if we ask for some random list 0, then we get the number 10. So what this means is that 10 is element 0, some string is element 1, 5.7 is element 2, and some other string is element 3. And the total length of this is 4. So what this means is that some random list 3 will give us the last element, and if we ask for element 4, it should give us an error. Yeah, index error, list index out of range. There's only 4 elements, so you can't get the 4th element out. So far, so good. Okay. Now, we can get elements out of a list in that particular way, but we can also, let me duplicate the list here, just so we can see it for reference. We can also ask for a sequence, like a subsequence of these elements. So to do that, what I do is I put the first element that I want. So let's say I want the middle 2 elements out of this. So the first element I want is element 1. That's some string. And then I put a colon, and then I put the number of the element after the last element I want. So if I want just these 2 elements, that's element 1 and element 2, then I would put 1:3, because 3 is the element that comes after the last element I want. So 1:3 looks like this. It's a list containing just the middle 2 elements. If instead I wanted the first 2 elements, I would say some random list 0:2. So that's 0, 1, and 2, with element 2 being the element after the last element I want. That gives me 10 and some string. So it's a little unintuitive that you have to put the element after the last element you want, but it kind of is a theme in a lot of the Python libraries. They kind of work this way, and it ends up working out on occasion, because especially if you start with 0, if the first element you want is 0, then this value here is the number of elements you want. So you notice that I got 2 elements out starting at 0. So that's one way to think about it. Something else you can do is request not every element, but every other element. So for example, if I say 0:4, that is, first of all, let's just look at this. If I ask for element 0 through element 4, well, element 0 is the first, and element 4 comes after the last element. So this will give me back the entire list, right? Even though there is no element 4, that's okay, because I'm not asking for element 4, I'm asking for all the elements up to, but not including element 4. Now, what if I want to get 10 and 5.7, but not these other 2 values? I can start by putting the exact same thing, but then I'm going to put a 2, so 0:4:2. And what this says is skip every other element. So when I run it, the first element, skip the next element, the third element, skip the next element, like that. If you're used to MATLAB, this is similar to MATLAB, except in MATLAB you put the 2 in the middle, I think. So it's just a little different that way. Additionally, if you're used to MATLAB, just a warning, you cannot use the end keyword in Python. You cannot say 0 colon ellipse. This is kind of common in MATLAB where you use end. That will not work. That will give you an error because Python doesn't know what end means. However, you can use negative numbers. So this is element 0, element 1, element 2, element 3. But this is also element -1, element -2, element -3, and element -4. So when you use negative numbers, you're counting from the back of the list forward. So if I say some random list 0 to -1, what someone tell me what they think the result is going to be when I ask for 0 to -1.
Will it just be the last one, or it won't be anything?
Okay, so this is a little tricky, but the what you can do to understand this is to substitute -1 for the forward value. So this is 0 or -4. This is 1 or -2. Sorry, -3. This is 3 or -2. And sorry, I keep saying the wrong one. 0 or -4, 1 or -3, 2 or -2, and 3 or -1. So you can substitute the -1 with a 3. So what we get is the first 3 elements, because -1 is this element, and this value here after the colon is the value that comes after the last value we want. So this will give you these 3. If you don't know how long the list is, and let's suppose we want the last 2 elements of the list, but we don't know how long it is necessarily, there's a couple ways we could do this. One is we could say some random list, well, let's say n is equal to the length of some random list. And then we could say some random list n minus 2 colon n minus 1. Now we could run this, but notice that it's only going to give us back 5.7. It's not giving us back this last element because we ended with n minus 1 and it doesn't give you the last element. So instead, we can just leave that off and just put n minus 1 colon. And when you don't put anything there, it assumes that you want the whole rest of the list. Let me make this -2 so it's the same. Then we get, starting with the second to last element, we get the rest of the list, which is 5.7 and then some other string. And now notice here, I set n equal to the length of the list, but we don't actually need to do that even. We can just say -2 to the end, like that. So again, this -2 is the first element we want. So -1 minus 2 gives us 5.7. And then because we don't put anything after the colon, it gives us the rest of the list. And so we get 5.7 and some other string, and that looks like this. Okay, any questions on that? Okay, now this is also kind of general. You can leave the arguments for these. Oh yeah, go ahead. What's the question?
Sorry. So I just want to clarify. So when you're indexing from, left to right, going forward, the first index is 0, but when you're going from the end, the first one is -1. That's
right. Yeah. And that's because 0 always has to refer to this first element. So you can't have a -0 is equal to 0. So we start with -1 for the end. Yeah. Yep. Okay. The other thing is that so we saw how you don't have to put the argument here and it will assume that you want to go to the end of the list. The same is true for the first argument. So if I just put colon -2, that will give me everything up to, but not including the second to the last element, because it will assume that I want to put a 0 here if you don't put anything. So that will give us 10 and then some string, because the first 2 elements are 10 and then some string. Okay. All right, so that's how, sorry, my Jupyter froze for a second. Okay, that's how lists work. There's another kind of object that's very similar to a list. We're just going to talk about it really quickly here. It's called a tuple. So let's make a tuple that's very similar. We're going to have at least 10 and then some string, and then 5.7 and then some other string, just like our list. All right, and then we can print it or have it evaluated. And you notice that instead of square brackets, I used parentheses. That's the only real difference, though. Now, there are a couple things about tuples. Sorry, there seems to be some bugs in our Jupyter lab installation. So I don't know if you all are noticing the same kind of issues moving between cells as I am, but occasionally the cells seem to freeze. Sorry about that. All right, so with a list, if I put 10 in a list by itself, that gives me back just a list 10. There's something a little weird about tuples, which is that if I put 10 in parentheses, Python just thinks that I don't want this to be a tuple. It thinks I'm just putting 10 in parentheses as like a grouping kind of symbol. So this will give me back just 10, not a tuple containing 10. So if I want to explicitly say that this is a tuple, I have to put a comma here. And even though it's just a one element tuple, that comma tells Python that this is a tuple. These parentheses are making a tuple and not like a precedence grouping. So if I evaluate this, I now get a tuple back. Okay, so this is just how you make a one element tuple. The other thing that's kind of weird about tuples is that they're what we call immutable. So I haven't shown you this, but suppose we want to change the first element of our list to be a 1 instead of a 10. So let me just print out that list again. 10 some string, 5.7 some other string. If I want to change the first element of this list to be a 1, I can say some random list element 0 equals 1, just like that. And if I evaluate that, it doesn't appear to do anything as usual with assignments. But now, if I look at some random list, you can see that the first element has been set to a 1. So that's how you can update the elements of a list. With a tuple, you can't do this. This is the main difference between lists and tuples, is that with a tuple, if I try to set the first element to a 1, it's going to give me an error. It says, tuple object does not support item assignment. This is because tuples are meant to be permanent. Like you can sometimes use tuples when you're passing around information that you don't want to be changed. So tuples never change. Once you've made a tuple, it's just that tuple. For the most part, that won't be a very big issue in a lot of your coding. You'll see tuples, but it's not really necessary that you use them. Usually you can use a list and be just fine. Okay. All right, let's talk about another type of object. We've seen lists and tuples, but a kind of more, I think a more useful kind of object most of the time is what's called a dictionary. So a common thing that you need to do is you've got data that has some kind of name that's mapped to some kind of value. It's not a list really. It's more like assignments of values with like a subject's name or something like that. So let's suppose that we have a few subjects. We have a list of subjects. Oops. Okay, these are our subjects. And what we want to do is we want to store, let's say we want to store the age of each subject. One thing we could do is say subject ages equals, and then we could say like 31, 22, 25. Whoops. We could store the subject ages like this, and then if we're looking for subject 1, we would have to figure out that subject 1 is the 0th element of subs, and we would have to look up the 0th element of subject ages, right? So a better way to store this might be to use a dictionary. So dictionaries, kind of like lists and tuples, use curly brackets instead of open parentheses, or instead of regular parentheses or square brackets. And they have a list of elements, kind of like a list or a tuple, but the lists consist of a key and a value separated by a colon. So what I'll do is write out this list and then we'll kind of explain it. So sorry, this dictionary. So for the first element, the key is going to be sub001, the subject's name, and the age is going to be 31. For the second element, we have sub002 and the age is 22. And for the third element, we have sub003 and the age is 25. Okay, so we've made that dictionary. Now to get an element of the dictionary, it's a lot like with a list. So with a list, when we want an element, we ask for the element by its index number. For a dictionary, we ask for it by its key. So if I want to look up the age of subject 2, I just put subject 002, the string, in these square brackets. And what it gives back is 22, which is the value for subject 002. Similarly, if subject age is sub 001, I'll get back 31. Any questions about that? Does that make sense?
Wait, so which one is the key and which one the key is subject?
Yeah, the key is the thing that comes before the colon, and the value is the thing that comes after the colon. Okay. Yeah. So there, we call them key value pairs, and you notice that each key value pair is separated by a comma, kind of like how each element of the list is separated by a comma. But a key value pair has a colon that separates the key and the value. In dictionaries, you look things up by keys, and it gives you back the value. Now, dictionaries, kind of like lists, you don't have to have the same kind of value in them. So we could, for example, have subject ages equals sub 001 colon 31, and then maybe subject 2 declined to provide an age, so we just put none. And then sub 003 provided an age, but did so with a lot of specificity, so we know that they're 25¼ years old. Here we have a none type, here we have an integer, and here we have a floating point number. That's fine. We can declare dictionaries that have multiple types, and that will still work. So we can now look up some 003, and we get back 25.25. So this is true not just of the values. You can also have dictionaries with different kinds of keys. So we can say the first element of this dictionary is has a key that's a string, and the second element of this dictionary has a key that's a number. Now this is a kind of weird dictionary, but nonetheless it's perfectly valid. So we can say, oops, we can say what's the value for example key 1, and it gives us back a 1 because this is the value for this key. And we can say what is the value for 10, and it gives us back example value 2 because this is the value for this key. Now it's generally you don't need to do this, but it is totally possible, and you're totally allowed to do that. And assignment for dictionaries is pretty much exactly the same as you'd expect. So let's suppose that we look at this subject ages. I'm just going to copy and paste this down here. We look at our subject ages dictionary, and along comes subject 2, and they give us an age now. So we want to update subject ages, so we would say subject ages sub 002 equals 22, since we now have their age. And that's once we run that, we can see that subject ages, subject 2's age is now entered as 22. All right, does that make sense so far? Okay. So let me refer back to our lesson plan real quick. So we've talked about containers now. I'm not going to talk a little about everything. Oh yeah, go ahead.
So can one variable have multiple keys?
Can one variable have multiple keys?
So can subject have like an age and a date and something else? They can have multiple keys.
So typically, if you wanted to do that, you would do it in some other way. So one example would be you would say sub 001, and then you would have another dictionary here that had like age, 25, name, whatever. You could have another dictionary in here. That's one way you might do that. That said, there's nothing stopping values from being repeated in a dictionary, but each key has to be unique. So if you have sub 001, it can only be mapped to one value. And if you try to overwrite it, it'll overwrite it. It won't insert it. Does that answer your question? Cool. Okay, so the next thing on our itinerary is talking about how everything is an object. And we'll do this just very quickly because I want to make sure we get through control flow before we finish. I'm going to delete this if I can. Yeah, okay. I mentioned earlier that I've used the term object a little bit loosely. So object is actually a special kind of thing in Python. An object objects basically are pieces of data in the Python system. So literally everything you interact with in Python is an object. So numbers are objects, strings are objects, containers are objects. They're all specific kinds of objects. And that's because Python is what's called an object-oriented language. We're not going to focus very much on the object-oriented features of Python. There's a whole lot to know about object orientation as a kind of programming strategy. It involves declaring kinds of objects and their relationships to each other. So as an example, in the Python library I maintain, the neuroscience library I maintain, which is called NeuroPython, there's a kind of object which is called a mesh. And then there's another kind of object which is called a cortex. And a cortex is actually a kind of mesh because all cortical objects in this library are represented as a mesh that describes the structure of the brain. Mesh is just a kind of cortex, and they share properties, and they're related to each other. You can think of this similarly with like numbers. In a sense, a Boolean is kind of like a kind of integer, although that's not a great example because in Python they don't strictly inherit from each other. Regardless, the point is that everything in Python, strings, functions, dictionaries, they're all objects, and as a result, all of them can support methods, which we mentioned earlier. So just as a quick example, subject ages has a method called get. And the cool thing about get, let me delete this since we didn't actually run it. Get is kind of like just using the brackets. So if we said subj 22, whoops, 02, we should get back the value 22. However, let's suppose we want to get subject 4. Well, there is no subject 4 in this dictionary, right? So when we try to get it, if we just tried to get it with the brackets, we're going to get an error because that key doesn't exist. See, key error. There's no subject 4 in our dictionary. The get function, however, will return none if it's not in there. And we can optionally give it a second argument that's a default value. So since there is no subject 4, it's going to return this default value string instead of giving us an error. On the other hand, if we change this back to 002, since there is a subject 002, it'll give us back the subject's value and not give us the default value. So this is just an example of another kind of method. Literally everything in Python, every number, every string, they're all objects and they all support some methods. And just as kind of a tip, there's a built-in function called dir for directory, and you can pass it an object, and it will give us back a great big list of every kind of method or bit of information attached to that object. A lot of these start with double underscore, and you can pretty much ignore them. These are kind of like built-in special Python functions. But you see there's a whole bunch of different methods here. For example, keys will give you a list of keys. So if we just run subject ages.keys, we get back a list that contains subject 001, subject 002, and subject 003. Those are the 3 keys in the dictionary. So dir is a handy little function that you can use to get a list of all the methods attached to an object. Any questions about that? Okay. One more thing about objects is that there's another built-in function called type. Type just tells you what kind of object something is. So if I run type on this string, it'll tell me that it's a string. str is the name of the strings in Python. If we ask for the type of 10, it'll tell us it's an int. If we ask for the type of 10.0, it'll tell us it's a floating point number. So type gives us back the kind of object this object is known as. So kind of useful. Okay, let's talk about control flow. And control flow is pretty important because it's how you tell your program to do one thing instead of another. So it's pretty important for just about anything. So let's look at an example. Let's say we have the price of a mango is 0.2, 20 cents. So we want to write a program that will print out whether or not you should buy a mango based on whether the price is cheap or not. So in order to do that, we need to be able to say, if the price is beneath some value, do something, and otherwise do something else. This is accomplished in Python using a command called if, which is pretty much the command in every programming language. It's always if. So we would say if mango price, let's say, is less than 50 cents. So we say if mango price less than 50, and then we put a colon, and we go to a new line. And you notice that it automatically indents this line. We'll come back to that in just a second, but for now we'll just say print mangoes are super cheap. Get a bunch of them. Okay, and then we're going to backspace back to the beginning of the line, and we're going to say, for now we'll just say else print meh. I don't really even like mangoes. Okay. Whoops. All right. So now when we run this, what's going to happen is, of course, first of all, it's going to assign mango price the value 0.2. And then it's going to come down to this set of lines. And first it's going to say, okay, mango price less than 0.5. Well, that's true. And it's going to say if true. And because this evaluates to true, it's going to run the code here. So let's go ahead and try that. If I push Shift Enter, I get mangoes are super cheap. Get a bunch of them. So as we expected, since mango price is less than 50, it printed this. But it did not print this because this is part of what's called the else block of the if statement. Now, let's suppose we change this to 0.8. So now mangoes are 80 cents. This little bit of code will evaluate to false. And so rather than doing this part, the ifs block, it'll do the else block. So if we run it now, we get the other results. Meh, I don't even like mangoes. So this is a very simple if-else block. Just to show you a couple things. First of all, you don't have to have an else block. If you don't have an else block, it'll just do nothing should the condition not be triggered. So in this case, mango price is not less than 50, so this won't be printed, and in fact, nothing will happen. We get no output. Okay, I'm going to put that back in. Now, I mentioned, you noticed that there was an automatic indentation of this line when we pushed enter, and that would happen again if I push enter here. It automatically indents. And that's important because Python is a language that actually cares very deeply about white space in your code. So if you're used to like C or C++ or Java or a variety of other languages, these are languages where you're encouraged to use spaces and tabs to make your code look nice, but where it doesn't actually matter if you use them. The language will work perfectly well if you put everything on just one big messy line of code. That is not true in Python. In Python, you have to use white space in order to make things make sense. So whenever you have a line like this, like an if statement or an else statement that ends with a colon, you're going to need to indent the next line. And in fact, you're going to have to indent every line that comes after it in order for it to be considered part of that block. So let's suppose we wanted to print this and then we wanted to print something else. These are now both part of the same block. So if I change this back to point two will run both of these statements. You can just see how that works. And we could have a similar thing here, where I'm just going to switch that back. So now it should go into the else block, and it prints both of these. If, on the other hand, we had not indented this line, what do you think will happen now?
It's going to print those 3 dots regardless of the if else.
Correct. Yeah. So the first time we run this, I'm going to keep mangoes at the same price. It's going to look exactly the same, because what happens is it goes into this else block, it prints this, and then it goes on to the end of the block and goes on to the next line and prints the dot, dot, dot. But if I change this to point 2, it'll go into this block. It'll print mangoes are super cheap, got a bunch of them. Yay, I love mangoes. It'll skip the else block, but this is the only line that's in the else block. So it'll go ahead and print the dot, dot, dot anyway. So when we run this now, we get all 3 lines. Okay, everyone follow that? Does that make sense to everyone? All right, so I'm going to delete this line. And we'll add one more condition here. So let's, sometimes you want to say if something else, if something else, like there's multiple conditions. So in theory, one way you could do this is you could say else if mango price is less than 1, let's say get just 1 mango from the store, and then we'll say else like this. This is one way we could do this. And now if we run it where mangoes are 0.2, we still get this first if block. We get mangoes are so cheap. If mangoes are now 0.6, we won't get this first if block, but we will get this second block, and it'll skip this else. So we'll get 1 mango from the store, and then if mangoes are like $1.60, we'll get this last block. So that's one way to do it, but a cleaner way we can do it is to say, I'll just reproduce this. Mango price is $1.60, and we'll say if mango is less than 0.5, and just this one line. And then we'll use a variant of the if line called elif. This is short for else if. So we can say if, elif mango price is less than 1.0, print get just 1, sorry, I need to scroll down. Store. And then we can have finally an else, and we can print Okay, so now this is basically exactly the same logic as this logic block. It's just that we shortened it using an else if. And since this if and else are only ever going to be triggered when this else is run, these are exactly the same logic. This is just a shorter way to say it. So when mango price is $1.60, we won't fall into this. We won't fall into this, and we'll finally fall into the else. If mango prices are 60 cents, we won't fall into this first block, but we will fall into the else if. And finally, if they're 20 cents, we fall into the first block. All right, everyone understand ifs and else ifs? Any questions? Cool. Okay, so let's go on and talk about loops, which are the next most important control flow. So a lot of times you want to loop over a lot of things, like either you want to count something or you have a list that you need to look through. So recall that we made some random list earlier, which contains these values. Let's suppose we just want to loop through the list and print out each value on a separate. So the way we would do that is we would use a loop. And by far the most common kind of loop is what's called the for loop. And the way we use a for loop is we say for element in some random list, and then we put a colon. And then when we push enter, we'll get an indentation on the next line. And we'll go ahead and say print element. I'm just going to go ahead and push shift enter to evaluate this. And what this is going to do is it's going to, well, let's go ahead and run it and see what it does. Okay, so basically what happens is for each of the elements in one random list, one at a time, starting with 1 and then some string and then 5.7 and then some other string, it's going to assign the variable element that value from the list. And then it's going to evaluate whatever's in this block using that element. So basically what this does is it starts by saying, okay, the first element of some random list is 1, so we're going to assign element to 1, and then we'll run this, which is just print 1, and it prints 1. And then we go and get the second element, some string, we assign that to the value element, and then we print that, and we get some string, etc. So for loops like this are just a very easy way to kind of loop through a list. So let's make this just a little more complicated. Let's suppose we only want to print out values in this list if they're a string. We don't want to print out the numbers. So we'll go ahead and say for elements in some random list. Then we'll say we're going to use a function called isInstance. IsInstance is a function that checks whether a particular value is an instance of some particular type. So remember earlier, and I'll just go ahead and run this up here as a reminder. We looked at the type value, type function, and if we ran it on a string, we got back string. This is a type for string. So what we're going to do is we're going to ask if element is an instance of the string type. And if it is, we're going to print element. Otherwise, we're just going to ignore it. So we don't need an else, but something you can do just to make your code more readable sometimes is to say else and then say pass. Pass does nothing. It's just kind of a placeholder. It says there's nothing in this else block, but it makes it kind of, people kind of look for an else when they see an if, so it can kind of make it clear sometimes. Okay, so I'll go ahead and run this. And you'll see that it prints out some string and some other string, but not the numbers. And that's because for the numbers aren't instances of string, and so they don't get printed. All right. Now let's suppose that we want to do something like this, but instead of just printing the strings, we also want to collect up the numbers. So the idea is we're going to run this block of code. It's going to print out the strings, and then at the end we want to have a list of the numbers that were in our original list. So we're going to start by declaring an empty list called numbers from list. That numbers from list is going to collect the numbers from our random list here. And we're just going to declare that to be an empty list. And then we're going to say for element in some random list. And just like we did before, we're going to say if is instance of element of an instance of string. Then if it's a string, we're going to print it. Otherwise, if it's not a string, we're going to assume it's a number, and we're going to use a method called append. So numbers from list is list, and among its various methods, it has one called append. And we're just going to append the element to the list. And what append does is it just takes this list and adds an element to the end. So at the end, we're going to print found some numbers, numbers from list. So let's go ahead and run that. Uh-oh, I got an error. Number from list, I misspelled numbers. Okay, so I'll fix that up here. I'll try that again. I misspelled element. So I fixed that typo. There we go. Okay, so to kind of follow this, let's just remind ourselves what's in some random list. So this will first assign element to 1. 1 is not an instance of a string, so it calls numbers from list.append 1, then it goes to the next element of the loop. Some string is a string, so it prints it, which we see here. It then does the same thing for 5.7 and some other string, so we see some other string printed here. And then finally, we print numbers from list at the end, and we see that it's a list containing 1 and 5.7. So this basically worked as we expected. Any questions on the stuff we've covered so far? Okay. So we've covered most of the stuff that I wanted to cover. I think, and we'll kind of pick up in the advanced Python tutorial tomorrow. But in the last few minutes here, I just want to cover a couple things. The first is importing things from libraries. Earlier, I tried to show you a function called a log function, and it didn't work because there wasn't a built-in log function. That's because there are libraries for math functions that contain those functions. And if we want to use those libraries, we use a command called import. So let's suppose I want to use the log function. I'm going to import math. Math is the name of a common Python library. It's a built-in library, basically, but you don't have access to the functions and objects in math unless you import them. So I'm going to import math. And now you notice there's no output there. But if I then evaluate math, you notice that it says it's a module, and there's some directory where you can find that module in the file system. But basically, a module is a special kind of Python object, and it will contain a bunch of different objects of its own. So for example, math contains a function called log, which we can see here. It's a function. And if we call the log of 5.0, for example, we'll get some floating point number back, which is the log of 5.0. Another important value in math is math.py. You may need to use that value at some point. If you want to see what else is in math, we can say dir math, just like we did with objects previously, and you'll see some hidden Python things, and then you can see a bunch of other math functions. So arctangent and isnan and log base 2 and lots of other things. There's all kinds of mathematical functions built in. We'll talk more about mathematical functions tomorrow when we talk about NumPy and more advanced topics. But the important thing here is that we imported the math module, and then we could refer to it as math. Sometimes you don't want to import the whole module. Sometimes you just want to get one function from it. So as an example, we might say, instead of import math, we might say from math import pi. When we do that, what we get instead of the whole math library is just the pi variable. So once we've done that, we don't need to do math.py, we can just evaluate pi. That said, that isn't fundamentally different than if we had said import math, and then we said something like e equals math.e. We can do that as well, and then e is equal to the value of e from math. That's not really much different, but this is how you would generally do it. It's just kind of a stylistic choice. There are lots and lots of libraries for Python. That's one of the best things about Python, is that almost any problem you want to solve, someone has already solved it and put it in a library, and you can just import the library. We won't have time in this course to go through every possible Python library, but we will be talking about various neuroscience libraries and other tutorials and other lectures. So tomorrow in the advanced Python, we will talk about NumPy, which is a very critical Python library, and Pandas, which is another one. But we'll also be talking about NiPy and NeBabel and some of these other neuroscience specific libraries in the other lectures. All right, so we'll talk more about that tomorrow. The only thing I kind of wanted to get through is defining functions that we didn't get through, but we can talk about that tomorrow too. Just as a quick example, it's okay if this goes by a little fast, but I just want to show you kind of how it's done. If I can get a blank cell here. Okay, so let's suppose we wanted to declare our own version of the log function, like Like we want to have a special log function for calculating the log of 3 or something. So if I want to declare a function, I might say def log 3 and of x. And basically this is saying I'm going to define a new function. Its name is log3, and it takes one argument, which I'm going to call x. Now I indent this next part, and everything that's indented below here is part of the function. So if you want to calculate the log of a different base, let's see if I can get this right. The first thing I want to do in this function is import math so that I have access to the math log function. I'm then going to say log base e of x is equal to math.log of x. And then I'm going to say log base e of 3 is math.log of 3. And then the log base 3 of x is equal to log base e of x divided by log base 3 of x. I got, if I got that formula wrong, please correct me, but I think that's right. And that's the answer we're calculating. That is how we calculate the log base 3 of x. Yeah.
Wait,
Your question?
should it be log x divided by log 3?
Yes, that's you're right. I typed this wrong. You're totally right. Log base e of 3. Thank you. So we have the result here. This is the value we want to return from this function. So the last thing we need to do is just say return log 3 of x. And what will happen when we call log 3 is it will run all this code. It will import math. It will calculate these logs, divide them, and then return the value. So I'll go ahead and push Shift Enter, and that defines that function. And now that it's defined, I can call something like log base 3 of, let's do 9. And we get back 2 because 3 squared is 9. So that's how you define functions. And with that, we're pretty much out of time. This went really fast. So if you have any questions, feel free to ask, or if you want, you can always put questions in the Slack channel for the Python tutorials. And I'll get around to asking them as best I can. We'll pick up tomorrow with advanced Python. We'll talk about NumPy and Pandas, which are more useful data science libraries that kind of build on what we've talked about so far today. But with that, thanks for joining, and I'd be happy to stick with questions for a while if you have any additional questions.
Thank you. That was really helpful. I had a small question. So when you generally just code in Python, do you usually code in Jupyter, or do you use Sublime or like a shell script?
Yes, that's a great question. I personally use Emacs, but I'm weird like that. Emacs is like a low-level text editor. So I wouldn't necessarily recommend Emacs unless you're already an Emacs person. The way I code in Python is that I'm typically in a Jupyter notebook writing like a function like this and testing it, and then editing the code a little bit and be like, oh, I typed that wrong, I'm going to fix it and then test it again. And then once I've gotten all of that code more or less running in the notebook, I just copy it all and I go over to my favorite text editor, which maybe for you is Spider or Sublime or one of those, VS Code. And I put it in my code in the editor, and I save things there. The reason, and we didn't talk about this, but the reason that I don't usually try to save code in a Jupyter notebook is because Jupyter does not work very well with GitHub. So Jupyter notebooks are in a fancy JSON format, and when you try to like merge a Jupyter notebook on GitHub, you'll get back this really ugly, incomprehensible merge log. And so it's really hard to share code in a notebook, but they're great for like evaluating things as you're going, documenting things, making plots, that kind of stuff. We'll do more of that tomorrow.